Welcome to the fourth class in data analytics, where we explore interactive visualization, probabilistic modeling, and machine learning tools and techniques applied to the problem of analyzing data, by which we means we take raw data or formatted, curated data, and we mine it for information, and then we extract insight from said information set into, I guess, supporting optimal decision making. Okay. Now, let me emphasize that again, even though I separated the course and correspondingly the class textbook into 3 or 4 modules, right? The first module that has to do with interactive visualization is what we're going to cover today, and maybe a little bit next week as well. What this one differs from probabilistic modeling and machine learning, in a sense, is that this is more like a quick win. In other words, the premise of interactive visualization is that if you can create the right visualization, choose the right perspective, the right dimension, the right visual language, you can actually infer, or you can actually get the insight right away. Okay, so there's no mathematical modeling or predictive AI or regression equation involved whatsoever. It's just that the data is there, and if you know how to pick the right dimension, right? Maybe a little bit manipulation, like instead of showing X1 and X5, maybe you show the ratio of X1 to X5 versus time, something like that. And just by picking the right dimension, the right ratio, the right perspective of looking at your data, the right slice and dice, as it were, you immediately get the insight that can be, can immediately lead to the optimal decision making. Or you can spot like what's the weak point in your manufacturing process, where is the bottleneck, or where is the highest, most performing line of business by comparing cost to revenue to cost, or manpower, or whatever. Okay, so that's essence of what we try to do today. Now, the first class we went over, right? The first class, essentially, we follow if we follow the textbook, the first class is really here, right? The introduction to data analytics. So we talk about the concept of data. And by the way, this is very important. Some of it is like very simple. What's the concept? What's the data point? What's the data set? What's nominal, ratio, interval, nominal, ordinal scale, and so forth. Right. And then we spent a good two weeks on the core language of Mathematica. Maybe 2 weeks ago in class 2, right? We sort of like focus on Mathematica as a scientific computation platform, which has evolved into, a general purpose language. It's also evolved into like a larger ecosystem where you have a library of data, you have a library of function, you have a community of user, you have some kind of knowledge base that's linked to computation in the form of Wolfram Alpha, right? All the way to present day, which is Wolfram Alpha is probably the most popular, certainly in my estimation, the most important add-in or back-end to the ChatGPT, right? As you know, ChatGPT is well, it's like a chatbot. If you use if you just have a ChatGPT, you go to ChatGPT, it's like a chatbot. You ask it anything, it gives you some answer. But if you wanted to do something more, I guess, industrial strength, something of more substance, right? Then you would have to ask ChatGPT to connect to the back-end computational module. And the most important computational module, which is, again, part of, I guess, ChatGPT plus subscription, is the Alpha, the Wolfram Alpha, okay, which is basically the same engine that drives Mathematica. Okay, so now instead of thinking of ChatGPT as a fun conversation thing or a quick and dirty way to write an essay for you, then it becomes more like like an operating system, like like your phone, right? You have a phone that's an operating system because you can plug in all kind of apps. Well, you can think of ChatGPT as sort of like an interface with you that connect you to all the back-end application. And the most important application, as far as last I checked, is the Wolfram Alpha, which is, again, you can think of it as Mathematica plus Wikipedia or something like that. Okay, that's it. So that was the first week, right? Okay, we talk about cloud deployment of your application, and this is something that we'll come back to. And this is going to be useful for the proof of concept in your project. You come up with some kind of, instead of just using, what's the thing called when you use, you draw an interface, Flash or something, anyway, you just draw little buttons and pretend that this button works, right? Now you can actually have buttons that works, right? And then just deploy it in the cloud. Don't have to take the program with you. It's a bit slow, but conceptually you can just give the URL to your client or whoever you want to pitch the idea to. And so once you cloud deploy, this becomes something that you can access online and play with, right? And then last week was when we spent a proper language, right? Proper introduction to the language, the grammar and the vocabulary. Okay. So anybody remember the key concept? What's the most primitive? Well, the first thing I want you to understand as a concept primitive is, well, you can't do any kind of programming unless you do it as an assignment, right? Assignment looks like an equation, except it's an equation that you make yourself. So, you know, A is equal to B is a statement. But if you use it as an assignment, A is equal to B, that means you have the value for B and you assign it to A. You make sure, so it's not a statement, it's a command, right? A is equal to B is equal, means you are telling the computer from now on, every time I call an A, it's the same thing as calling a B, right? So X equal to 7, that's not a question, right? That's a statement. But that's not more than a statement. It's a statement that is true the minute you shift enter because you make an assignment. So assignment is the most basic, the most primitive thing you can think of, right? When it comes to, you know, programming primitive. Of course, hello world is even more primitive, but never mind. And the second thing is we go to the concept of, okay, let me go. Let me compress some of this, right? So this is right? So this is the concept of assignment. Now, in any kind of programming language, you don't want to work with one object. You tend to want to work with a whole bunch of things. That's the whole point of computer efficiency. So invariably, you're going to be working with some kind of list, right? And that list, you can think of it as a storage, okay? So you have a cabinet that has a top shelf, second shelf, third shelf, fourth shelf. You can put anything in there and just access it by the shelf number. Okay, well, that's useful. But what's more useful is when the individual item in the shelf represent similar sort of thing. So whatever you do to the top shelf, you can do to the second shelf, third shelf, fourth, so on, so that you can have 5,000 shelves in one cabinet, and you say, do something, all the shelves, right? And that's sort of like, this is the iterative nature of programming. So this concept of list is very important. Now, we are dealing with what's called functional programming paradigm, which is to say that the way we tell the computer or we ask the computer to do something is to call the function that the computer knows, right? So please make me an omelet. In computer speak would be calling a function called make an omelet, right? And of course, this functionality has to be something that grows, right? So, well, you can say that the language itself grew. So Mathematica 1 maybe has 500 built-in function. By the time we get to Mathematica 10, it has maybe 5,000 function. So these are all built-in function that grows with every version of the language. Okay. How else can it grow? It grows because you take a bunch of built-in function, right? You string them up in some kind of logical order, some kind of functional relationship that reflect what you want to do. And that becomes your own recipe. And since you're going to use that recipe more than once, you might as well name it. So that's kind of like a user-defined. Now, of course, the intermediate step is user-defined, but you don't want to use it many times. You can do what's called pure function, which is like the function you define and use it once and throw it away, right? Say like, take the first item from a shelf, add it to second item, and divide by the third item from the shelf. You want to do it once, and you can use, yeah, you don't have to name this because it's not that special. But certainly, if you have a function that you define that involve like, 50 steps or 20 steps or even 3 steps or 2 steps or maybe even just 1 step, but it's something that's you're going to find very useful. You're going to use it again and again and again and again. You might as well define it, right? In fact, if you open the textbook, you can see that there are some function that I already defined right here, which is kind of like next to the prologue. The reason I have this defined in the very beginning of the book is because it's one of those convenient formatting function, like presenting a table with a nice blue header and rectangle or something like that. So this is sort of like something that I define. There's a function that say, for whatever distribution, show me what the mean, what's the standard deviation. So this is something I'm going to be using a lot, and I might as well define it at the beginning of the book, which is why it appears even before chapter 1. Okay, so in a live version, you would shift enter, but I actually gave you this blue thing. I make the background blue just so it's that this is something I define, right? So I call this like a header file. Okay, so this header file that I sent you probably in the first class or the second class, if you lost it, I'll send you again. Okay, so this is something that, for example, the table is a formatting function. Okay, all it does is just show a bunch of things in the item. Okay, fine. So we talk about the language and all the way mathematical one, the concept of notebook, right? That you obviously will see that this kind of like kernel that you can expand and then hide and then copy as a cell, that sort of thing. Cell, sometimes I use the word cell, okay? But you can also use the word kernel, okay? And that's something that should be also familiar to people who program in Python using Jupyter Notebook, because Jupyter Notebook was modeled after Mathematica Notebook. In fact, Mathematica Notebook has, what's the last name? .nb, right? What do you do when you save Python file in Jupyter Notebook? IPYNB, Interactive Python Notebook. Okay, so extension of that notebook concept from Mathematica. Obviously, Mathematica is first. That's why it doesn't have to say MNB, Mathematica Notebook. It just say NB. It's the concept of computable notebook that was kind of fairly novel at the time. Okay. So I talk about, language paradigm, right? Mathematica. It's a computational platform. It's got all kind of basic knowledge built in. Knowledge about human physiology, biology, chemistry, and so forth. And these are things that I show you. And then we'll talk about this software and database system. Okay, right. And so last week was really here. Okay, assignment list function. Okay, so concept of function, and that's it. Oops, sorry. Function, let's collapse this, right? And then once I got to the concept of function, I start with the univariate, then we go to multivariate, right? Now remember the critical point, univariate, that doesn't mean you stick in one thing, because that one thing could be a list, right? So it's univariate because it called one object, but that one object could be the whole shelves of things, okay? Now, a multivariate, doesn't mean that you have two variables. It just means you have two places to put things. Usually they serve different function. For example, the first one is a string. The second one is a query to look whether or not this text is part of the first string. Okay, so it doesn't make sense to have this as an object because it has two different functions, two different interpretation. Okay, so a function that takes one thing, and that one thing can be a list. So internally, it's not just one thing; it's a whole list of things. Fine, but you can also have a function that expects two items. Yeah, that's called item. The first item is a string. Second item is a search keyword, say. Okay, so obviously the string itself and the keyword, they serve different two interpretation. So you have to input two slots. So that's, we'll call that multivariate function. And then we go to this. I think we did cover some of this, right? Range function and all that. So this, because lists are so useful, okay, list construction is always going to be a very common. Okay, so go through your textbook now that you have that in your hand and try to literally, as you follow, key in yourself. Okay, in fact, that's the reason why I don't make this an sort of like a digital notebook, because I want you to type in everything yourself. Okay, so type in this range, try it, range 5, and then you can type in range 7. So this is a list construction. Okay. Now, list is the most basic form of organization in a computer language, okay? And what's the second one? Second one is more like a lookup table, okay? In Python, it's called dictionary. In Mathematica, it's called association, okay? So in other words, if the key is Apple, okay, the value could be an actual database that has to do with everything Apple. Okay, so this is what an association is, and we show you an construction like this, right? So this is a good one that you should type in yourself. Okay, and just for review, you should type it yourself. RGB association equal to this funny bracket, right? If the key is R, it points to the value rate. Okay, so once you've done this, okay, this becomes something that you can use. Let's go to the use page. Oops, sorry. New notebook, okay. So RGB R, right? So R is my key. So what do I get? I get this. Okay. Now, if I want to get the whole, all the keys, it's simply keys, right? And what are the values? Okay. Right. The idea is that there is deterministic call. Most of the time, it's obviously not like this, right? Most of the time, the value is not just a simple thing; it's a whole block of things. Okay, so it could be something like think of it as a database. Okay, so database of HR. Okay, HR database, and you put in something like Alice. Okay, and instead of getting just one thing, you get a whole record that has to do with when did Alice start working at this company, what's her salary, what's her last innovation or creative idea. It can be anything, right? Except you just say, okay, this is my database called Alice, and then if I build this. Now, the way of building this dictionary, of course, you can make it more, I guess, powerful. Make it more like a spreadsheet, right? Like an Excel. So you can do some kind of functional, like group by, pivot table. Presumably, you understand how those concepts work. Like in Excel, you can do VLOOKUP. It's a lot more powerful, right? So if you think of this as a basic correspondence looking up, how about something more powerful? And that in Python, you have to load in this library called pandas to create a data frame. Okay. In Mathematica, of course, you don't really load any package; it's already there. it's called data set. No, let me go. This is somewhere. Oops. Some further down the line. Okay, where's data set? I think data set somewhere here. Anyway, okay. Okay, now, as I mentioned to you, this is not, you know, sort of like a general introduction to mathematical programming just to get you to know the language, but rather the example I use are the function that I want you to know because I find them useful in working with data. So one of the you know way of constructing association is called association thread. All right. So basically, you take the keys and the list of key and list of values, and then you create that. So, okay. And okay, let me shrink this. Let's shrink this. Okay, useful operation on the list again. So counts, for example, that's used all the time. Okay, so it's not, again, this chapter is not a comprehensive. Okay, you can go to Mathematica online again with F1 or go to help. Right. So this is comprehensive. This has got all the 10,000 whatever function. Okay, but here I'm just picking out. I'm cherry picking the one that I find useful. Fine. Map is also useful. Okay, so these are the things that I really want you to. Now, yeah, during the say midterm exam, you can take in the book, right? You can take in the book, but if you haven't typed this in, play with it yourself, you know, you're going to be make a lot of error and not know how to do it. Okay, so just because I say you can take the book, that doesn't mean, oh, don't worry about it. I can, okay? Go through the exercise, line by line if possible. Now, this is the fun stuff, right? I said, okay, so these are built-in function, but these are sort of like get into the user-defined function. This is where programming or coding at your end is all about, right? You can think of the previous thing as some sort of like a built-in function. Think of it as a calculator. Think of it as a Excel spreadsheet, right? It has a lot of function built in, right? With Excel, you can do pivot, you can do sum, you can do average, you can do all kind of stuff with a whole bunch of numbers, right? With Excel, but you can't program procedures or steps, right? Now, the fun start right here. The fun start right here is when you start to string up a whole bunch of function and call it my own function, my own recipe, my own cooking, my own hack, my own shortcut for doing certain things. Okay, so this is where it gets to be fun. Now, I think I got to here, but confirm with me if you haven't. The concept of module. Basically, you make an assignment, you make a function, but if you make an assignment and you don't want to use it forever, but if you make an assignment, it's going to live forever. It's like something that's birth and not dead, right? It cannot die. X is equal to 7. It's going to be 7 forever until you turn off the computer or the program, right? Well, if you want to use it temporarily within the context, you have to wrap it inside the module. So basically, it's a way of fencing off a definition. So if the module is this class, when I say student 1, it only means you. Okay, when I go outside and I say student 1, it means nothing. Nobody knows what that means. Okay, so this is much better, right? Because I don't want to define student 1 as you forever. I just want to define in this room, you are student 1, you are student 2, right? And student 3 is supposed to join student 1 and student 2. All this only means something in this class. So that's how I wrap everything under the module. Again, I show you how it's done. Good example, run this through, right? So something like this is forever. No, that's not good. But if you wrap it inside here, then the color is green, right? Now, this is a question I should ask on the midterm just to confirm we understand. When you see something that's blue, it's something that's not defined. The computer doesn't know, right? When you see something that's black, computer knows what it is, exactly what it is. Well, how about green? It's something that's only known in a context. like inside the module, for example. Okay. Okay. All right. Now, before we go further, this is completely optional. It's called function shorthand. It just used so much, so often, you might as well learn about it. Ah, there it is. This is a data set. So this is a kind of, I could have put this sort of like right behind association. I'm not quite sure why I put it here. I think, oh, because I'm leading to the subject of file storage. Okay, maybe that's the reason. Okay, so data set is sort of like a more like an Excel version of association, right? You're not just looking up things, but you're doing, so you guys usually, I don't know if you've, it usually looks like this, guy, your data. Let's call Excel. Okay. I hope this is not all that new to you, but I can, okay. So this is something like a name, Alice, and then Bob, and then Chris, okay. And the sex is a girl, boy, girl, okay. And the status, yeah, student, teacher, okay. And maybe, I don't know, height, okay, something, right? So what happened if what I want to do is, and this is like not just 3 lines, but this is 10,000 lines, right? I want to do what? I want to say, what's an average height for a girl? Okay, what's an average height for a girl? What do I have to do if this was an Excel? Anybody? Well, I have to make this into like a table, right? And then I have to sort by sex. And then, so I do this and says, format as table, right? Table, format as table. Fine, format as table. Okay, good. That looks good. Let's do this. Okay. My table has a data. Okay. Now, and if I want to average just by sex, I have to do this, right? Sort by sex and then take an average. Okay. Now, next thing I want to do is I want to average by status. Then I have to do this again, right? It happens to be grouped already, so right. So it's not that convenient. So as an Excel, if you have something like group by some, take an average of this column if this column is G, or take average of this column is G and this column is student. So you can do all kind of stuff, right? So that's where all the programmatic database-ish function comes in. Well, all this I use so much, so often. People in Python world build a library called pandas to help with this. People in Mathematica basically just have this thing called dataset. Yeah, okay. So you can do kind of group by and stuff. Now, I'm not going to go into detail just yet, but later on in the semester, I may have like an example with like COVID data where this is what data looks like, okay? Countries and region and whatever, right? And I want to group by Asia. I want to group by a country that has vaccine or something like that, okay? So then we can work with data set. I encourage you now, if you are going to be in applied digital intelligence track, chances are you're going to have to learn Python anyway because it's more popular, it's more universal, right? So in that world, you cannot learn Python without pandas, okay? But if you within Mathematica alone, if you want to be more powerful in terms of manipulating tables and stuff like that, then you have to learn a lot of the functionality associated with data set. So, you go to data set, right? And then go to F1. Okay, that's it. So it has all kind of stuff, right? So basically it creates something that looks like an Excel without having to show the data, okay? And some of you may know that have had that experience already where you have the data so big, you load it up in Excel, it doesn't work because the data is too large if you work in the industry. Okay, so this is kind of all kind of operations you can play with, and these are the details you can play, and there's a lot of things you can do, items that, okay. So that's this guy, right? So let's collapse that. And then finally, this thing about file storage. So basically you have to read things in and out, right? Now this thing is basically sort of like language primitives. This is not that unique, okay? But what's unique is here. Now this part here, everything that I said so far here has a counterpart in Python world, okay? Everything down here, a lot of time you don't. Sometimes you have this library called SymPy or something like that. They try to build in back sort of like later. So some of this, it used to be that you can't do it in Python whatsoever. Now, some of it you could, not all. Okay, so this analytical function, okay, it has to do with the fact that it can compute symbolic. So I told you, so this, for example, is very real. This is taking a limit. Okay, this is something you would do in analytical mathematics. This is not that critical. Numerical computation engine, this is not unique to Mathematica. In fact, if you work with MATLAB, it's probably a faster numerical method library. Okay, semi-analytical, this is actually, I'm not going to talk about it now, but it's probably what makes it very powerful. Okay, so let's get to the subject of today. Okay, today is so this chapter, interactive visualization. Let's think of it as visualization without interaction first, and then interactive. Does that make sense? Okay, so when you make think of okay, let's go to example like Excel again. If you go to Excel, right, you can create a graph, a plot of something versus something, a history, something, right? You can make that. Now, what happened is when you use that in a presentation, sometimes people say, okay, well, you're plotting this GDP of different country, okay, and then you plotting population, and then somebody raised a hand. What about GDP per capita? Well, you may have prepared that, but the point is that wouldn't it be nice if you have this kind of interactivity where you say, okay, well, you have population, you have GDP. How about GDP per population or something like that? That's when you have things like Tableau. Okay, so you can think of this interactive visualization as a Tableau-ish functionalities. Okay, where the idea again is data analytics gives you insight. Some insight, you don't have to do much. Just plot the right axis, the right ratio, and you get the insight, right? The difference, of course, is that with Tableau, you have to do all the advanced computation somewhere else, import it as a database or as a flat file, and then Tableau will take over the visualization. Okay, whereas here it's end-to-end. So you can take the data, come in, build in machine learning. Once you build machine learning, you get the result you visualize. Now, in that case, yeah, you do have to do machine learning first. You can't just plot the data right away. But here's what I want you to remember. Here's what I want you to remember, okay? Number one, the value of interactive visualization is just like I said. If you plot the right axis, the right X versus the right Y, X1 divided by X5 versus X7, you get the right insight that you can act on. So it's immediate insight. That's value number one. Okay. Now, for our sake, as data scientists, we actually have another value. So I can imagine that I look at my data, my client's data, right? And one of the output they want is a dashboard. Well, that's exactly what this is. Interactive visualization gives them the insight on how their business is doing, how their various factory is producing this and that, and delay and customer satisfaction and all kind of stuff, right? So that's what they want. The value is the visualization. However, my data science client may want me to create a model that predicts something, predict demand, predict consumer response. So I have to build some kind of model with some kind of data that's given, right? Well, here is where interactive visualization or just visualization has double whammy, has two value. Number one, I'm a data scientist. I'm trying to build a model to analyze data, but data is something that I don't see. So I use visualization tools to help me as a professional data scientist understand my client's data. Okay. And once I've done that, I may never show this to anyone. I may not need to. Okay. I use it for myself. Okay, the insight sort of like helps me understand the client data. It guides my model building process. Once I do the model building, you know, AI or machine learning algorithm or regression equation or some kind of supervised, unsupervised tools, once I build it, I get insight. Again, the best way to communicate the insight to the client is to wrap it in interactive visualization. Okay, so if you talk about, you know, this book or this class, right? Data analytics, and has this three major part, right? Interactive visualization, probabilistic modeling, machine learning. Well, that interactive visualization part is in and of itself important because it builds data analytics in the form of interactive visualization. But for the second and the third part, which is probabilistic model and machine learning, in order to build that, the guy who builds it, the data scientist, me, I use visualization to help understand the data. And once I get the output from the model, I also display it using interactive visualization. Okay, so that's why it has to come first, and it's something that once you use it, you'll never not need it. You never not use it. Okay. Right. So again, this chapter has two parts, visualization and interactivity. Okay. So the visualization without interactivity, I'm just going to call it static visualization. That's literally what you've done all your life when you create a plot in Excel, right? Static visualization. Okay. So now I separated this. We go through that. Some sections are more relevant to data. Some are more to general design problem or something, but you know, we'll go through them. Okay. Well, because this is a mathematical computation, it was created as a mathematical scientific tool. The first thing we're going to visualize is not data. The first thing we're going to learn how to visualize is literally mathematical function, right? Right. Now, so from now on, okay, this is a matter of life and death. Never use the word graph to mean something like this. I'm going to make it completely illegal to use the word graph. Okay. So maybe in high school, you say graph the sine wave. Okay. The word for it is plot. Okay. And the reason I want you to not use the word graph is because in modern world, the word graph would refer to something else, has to do with the network and connectivity. So that word is no longer legal. Okay. Don't use that word anymore. Okay. This is not a graph. This is a plot. This is a plot. Okay. So type in just like this. Okay. Now, remember, there is something called like a natural language input where you don't know what to do, right? So you do equal, and it shows you this. Okay. So plot sine function. Shift enter, and it's going to make, this is sort of like you know, ChatGPT 20 years before ChatGPT. So like a natural language input. Okay. Now what it's going to do, and this is very important. I want you to notice a few things. It gives you this. This is you. This is you. It gives you this. What it does give you is a suggestion. Is this what you want? You want to plot the function of sine between -6 and +6, say. Okay. Now, it could give you something like from left to right, but you might not make sense. But the point is, once you do this, okay, confirm. Confirm, you just click it and say, okay, let's call it X. The reason this is kind of like, there's no X in there, you want to confirm it, so you put in X. There it is, right? So it's minus. So this, let me ask you this question. Is plot a univariate or multivariate function? In this case, it is multivariate because it has two things it requires. Notice, there it is. What's the first thing? The first thing is, what do you want to plot? What function do you want to plot? The second thing is, well, the function has to be over a range of X, right? So you have to specify the domain of function. So X from -6 to +6. Now, all this can be changed. By the way, this is just being very pedantic to evaluate sine of X. Because most of the time, unless this is something complicated, you can just say sine X. So you don't have another you don't need another function around it. You can just use sine X. It will get you the same thing. Okay. Now, why was the evaluation suggested? Because once you got this, you can plug in something else, and that something else may be like a numerical algorithm. And that numerical algorithm may take like 5 minutes. So sometimes you don't want to just, you know, redo everything, for example. Okay. So this is kind of like very advanced option. I myself never use. Okay. So evaluate. Okay. You never see this in my thing because, okay. Argument whose attribute specify that it should be held unevaluated. Okay. Why would you hold something unevaluated? Because you want to play with this code, but every time you hit the word, you hit this function, you have to go to a toilet for 5 minutes because it takes you 5 minutes every time. So you want to hold this thing unevaluated. So you can do that. Okay. Yeah. Yep. Yeah. See. So you can hold that. This is technical. This is, you know, don't worry about it. Okay. So that's why I eliminated that. So can you do this? Yes. Okay. Now this is where I want you to look at this. This a mandatory input, right? It's a bivariate. It has two placeholders. It has two items. The first item is what function to plot. The second item is what range to plot. That's it. You're done. However, there are options. Now, if I put another comma, it doesn't mean that this is necessarily a trivariate function because you already see that putting two things work, but sometimes you can put in another word. For example, one of the things I use all the time in the textbook is image size. Okay. And what you do is you type in image size. Okay. An arrow is just minus and then greater than, and it gives you sort of like a tiny suggestion, right? So this is a tiny. Sometimes you can use a value, for example, 300. So that's like a number of pixel or number of cell or something. Okay. Small. Okay. So now, if I don't put anything, it's the same thing as automatic. Okay. So image size is automatic. Happens to be that. Okay. So it's just now The reason I did this and I don't, well, the reason when I do this and I get a blue thing, you probably don't get this blue thing, right? Okay. Well, this is an option called filling. The reason I get it and you don't get it is because, well, let's go back to the beginning of this. This is why I put this thing like before all the chapter. See, this is called set option. Okay. So what I did here, just to show you that in the beginning, I set option for all these functions. For all these functions, I would say something like filling axis. Okay. See, so every time I use a plot, I have filling axis. So if you go to your own thing, you haven't set this as an option, you put in the option filling, okay, and then point, and it's going to have suggestion, right? Type it again. You just turn this in at the end of the class. So how about this? I change it to filling to top. Okay, filling to top, filling to none. I think that's the default option for everybody, right? Bottom. Yeah. So these are. So this has three items, but the third one is arbitrary and maybe something else. So I can have a image size small. Okay. Something like that. I can do color, I think. Okay. So plot style, maybe. Plot style. Dash, thick, dash, dash, dash. Okay. Right. So trust me when I say that the language is very friendly because it's a little bit more like a decorative. It's not, if it's functional, you have to tell it all the argument, but it feels like a decorative use of programming language because unless you specify, you can give it very vague top level instruction. Okay. And it's just going to come up with some kind of default that makes sense. Okay. To you, to everybody, the default is to have no filling. But for me, I like filling. So I said it in the beginning. But if I change my mind, I can always put it here. Okay. So all this here are functional argument, but they are completely optional. So if you didn't know any better, or if you don't want to be picky, right? If you don't want to be picky, you don't have to do any of this. Just so that's the deal. So that's the spirit. Okay, fine. So the first thing you want to view, the first thing you want to visualize is a function. Oops. If you look ahead in your textbook, you'll see a lot of this. Okay. It's okay, and you should take a look ahead. But what I don't want you to do is skip ahead and don't enter any lines. That's my philosophy, I guess. Okay, let's go. Okay, so what's the first thing we're gonna visualize? I'm gonna visualize mathematical function. So there it is. Okay, now this is a plot in 2D, right? So you don't have to write the word 2D. Now this is a 3D plot. Obviously, if it's a 3D plot, the output is a function of two variables, right? That's why 2 plus 1 is equal to 3. You have x1, you have x2, and then you have function of x1 and x2. It becomes a 3D plot, right? So if just a 2D plot, you need the function and you need the range of x. What do you think is going to be the minimum that you require here? You're going to require the range of both, right? Right? So in fact, this is what this is. It's a function of two variables. And the second and the third is the range. Now, let me show you that it doesn't really matter where you put the order because you have the name to it, right? So just Oh, it does. It does matter. Okay, because it's the first one. Okay, never mind. Sorry. Does it? Okay. So ignore what I said. Okay. So this is a function. This happened to be a function of sine multiplied by cosine. I'm still not convinced. Anyway. And this thing here from 0 to 2 pi and from 0 to 2 pi. Okay. So I don't know. Yeah, I'm not quite sure. And the image is small. Well, I don't have. Okay. So that's that. Okay. Now you can do anything. You can add plus xy, whatever. Plus xy. Oh, x blank y, because otherwise xy is another thing it doesn't know. Okay. So that's mathematical function. Okay. Once you've got this, you can rotate it about if you like. Okay. Now, once again, if you're listening, if you have a sharp a questioning mind, you can say, isn't the perspective an option? It sure is, right? So I can actually, by default, it looks like this. By default, it looks like this. Okay. Again, if you didn't say anything, it's going to do something. But if I wanted to, by default, show up like this, I can put in something like perspective. I think the word is perspective. I'm not quite sure. Or viewpoint. Sorry. Some of these you might need to go to ChatGPT to ask. Okay, viewpoint. Viewpoint is perspective. So for example, viewpoint is up front, above, or it even gives you suggestion. So let's try this one, right? Or maybe above or below. Okay. Or what was it? -1, 2, 3. Okay. Something like that. And you can even backtrack to infinity. Let's do that. Okay. Which is going to be similar to something like this. I do that, by the way. There's an animation in the book that uses viewpoint of minus infinity. Oops, where did it go? Okay. So if you didn't specify anything, it's just going to give you standard viewpoint. Okay. Now, this is, I'm going to go quickly because you're not going to use it all the time, but geometric object, they're like circle. These are things that are predefined. So, I can use things like graphic 3D to show cone, torus. When I say cone and torus, it's a decorative thing. It say, I want a cone, I want a torus. I haven't done anything with it. Well, I want to show the graphics. So there it is. Okay. And you can go to, obviously, it's actually in the book, so you don't have to take picture, but I don't mind. Okay. Anybody? Why did we say a bracket here? If all I'm doing is just a cone and a torus. Obviously, if there's a place to put parameter, you can put it, right? So obviously, this is kind of like a default parameter. So obviously, if you go to torus, see, you can put the input, location, size, or whatever, okay? But if you don't put anything, it's just going to give you a default. Okay. So obviously, see, that's a default, but if you give it some other size, it's going to be some other thing. Okay. Torus is a mathematical name for donut. That's what it is. Let me ask you a question. No. What kind of dimension is a torus? It's a donut, right? It lives in 3 dimensions. But if you ask the ant that crawls on top of the donut, it's 2 dimensions. Same as Earth. Exactly, well, not exactly, but similar to Earth. Earth is a 3-dimensional object, right? But when you walk on it, it's 2. Same thing. If you have a little ant, it's a torus. These are just fun things I throw in there because I thought it would look kind of cool. But these are something mathematician call knots. Okay, knots is very. It looks like a fun thing. It looks like a fun thing. It's very difficult mathematics, and I just throw in there. So these are example called knots, and they say, okay, crossing number. Okay, and when we go to the end of this class, we'll go to what's called a graph or network. There's something connection to that, but I'm just gonna. Now, okay. So 1.1 is visualizing mathematical object, right? Maybe a mathematical function, a mathematical object, right? But now let's visualize data. That's what we're all about, okay? Now we should get excited. So let's visualize 1D data. 1D data is what? You can't do much. What can you do? Raise your hand. I have nothing but the height of all students from the university. What can you do? You can do histogram, right? There it is. Okay. Oh, you can do leaf and stem, visualize. Okay. And if you have 2 dimensions, now it gets more interesting. Type in following. Type in the following. Okay. Okay. Type in the following. This is where you type in this. No, might as well. Let's do this. Let's do this. I want you to do this. Example data. Okay. Now shift enter. Now, these are things that you should play with. And in fact, today, with the first day, I give you actual homework to play with. And so these are things, these are example data. Okay, so this is even more convenient than working with, say, Wolfram Alpha, because that's real world data, right? This is not only just a real world data, these are real world data that are so small that you can play with it and look at it and examine every it's small basically. Okay, so these are example data set. So you can say aerial image. Okay, so let's do this. Okay, just say example. Okay, now this one, it's a list, so you put in as a, oops. Okay. Now, okay, it doesn't give you right away. That means that it has a subset, right? Subset. Let's go further down this rabbit hole. Let's do that. So it's not just aerial image, but it's Earth. Okay. And this is what I want you to do, but the homework will be on a different group, not aerial image. But let's play with this. So the argument here is basically the name of the data item. Okay, right? So something like that. So, well, the thing that I want you to play with is not arrow image, but in fact, statistics object. So let's go, let's go one step at a time. Okay. Now, let's see which one I was using was something about Well, let's do Old Faithful. Yeah, okay. So it's this guy. Old Faithful. Anybody been to Yellowstone National Park? Okay. We can use anything, but I want to use this one because it's the same one as in the book. Okay. Now, what it does is in this case, it gives you, okay, list of list. Okay. And this is the first time you're working with quote unquote real world data. Okay. It's called example data because it's so tiny and small, but it is real data. This is not fictitious. This is real data. Right. Well, let's look at description. User data, column heading, column description, eruption time in minutes, comma, waiting time to eruption times in minutes. Okay, basically this. Underneath, this geyser is like in a volcanic, in a tectonically active area of Earth, meaning that in the area you could conceivably have volcano. Okay, there's some like things underneath is not that packed, it's kind of loose. Okay, well, in this case, it's not a volcano, so don't worry about that. It's just something very hot down there. Okay, but what's actually underneath is some kind of like an underwater lake. Okay, it gets heated up by the magma. Okay, but the magma is not coming out, don't worry. It's just heated down there. So it heats this thing, it becomes a steam, right? Steams. So steam kind of build up pressure. And when the pressure is too much, it shoots up. And once it shoots up, obviously the water comes as well. So it's not just steam, but water, hot water and dirt and all kind of stuff. Well, the event is called eruption. Eruption time in minutes, it means how long the eruption takes. So 3 minutes mean 3 minutes. Waiting time to the next eruption in minutes. That means that once this thing has erupted, how long do you have to wait for the next one? Okay, makes sense, right? So if an eruption time is 1 minute and waiting time is 7 days, are you gonna travel to see it and wait around 7 days? It's probably not gonna be, right? It's not worth your vacation time. Well, things like that is worth it if it's like solar eclipse or something like that. You know, people would travel to South America just to view this solar event that happens here, and the next one would happen in 32 years. Okay, but you know, for a water display, it's not that exciting. Okay, fortunately, well, let's see what this data set looks like. So I type in that, right? But once I type in, it's lost. So let's call it my data. We'll call data equal to this. Okay, equal to this. Now, if I did this, you're going to see the data. Oops, sorry. I don't want the description anymore. I just want the data itself. Okay. Now, imagine that this is gazillion lines long, right? So chances are when you work in real application, it's going to be like this. Put a semicolon to it. It's a data. Okay. Trust me, it's a data set. Okay. But you don't get to see it because if you're going to bring it up, it's like bringing it up to an Excel. It's going to take forever. So yeah. Now, if you knew that this is a tabular data, which for most cases, until we get to chapter 7, it is tabular data, it's all going to be a series of, you know, a list of things, right? Remember I told you we work with lists? This is going to be a list. A list of what? A list of data points. A data set in this case is just a list of data points. Each data point has 2 numbers, eruption time and waiting time. Eruption time, waiting time in minutes. So it's going to be a whole bunch of shelves. Each shelf has 2 numbers. So what is this thing? It's a list of lists, right? It's a list of lists. The first item of that inside list is the eruption time. The second item, second of the list, the inside list is waiting time. And it's going to be like this. So you know that the dimension of this data set is going to be n times 2, where n is the number of events. Okay. Now, obviously, I want to know how many events. I would say length. By the way, I've shown you the shortcut, right? So if it's just a one variable, sometimes I would just say this, right? Or if I already type in data and I want to know what the length is, I do this, right? Okay, you know that. Okay, fine. So that's the length. Okay, but if I want the whole thing, right? It's not just a big rack of 272 shelves, but each shelf has 2 columns. So basically that's the number of rows. So if I don't use the word length, I use the word dimensions. There it is. Okay. It's a list of 272 things. Each thing is a list of 2 items. Now, I told you before that if the list has unequal length, it's not going to give you the second dimension. Okay. So what does this mean? If you open up this data set, you're going to see 272 pair of numbers, which are actual recording of how long the geyser shoots and how long you have to wait for the next one. Okay. Now, because it's a list, you can access it with list function, right? Data, take the first one. Okay. It lasts 3.6 minutes. Okay. And then you have to wait 79 minutes. So about an hour and a bit, right? And an hour and 30 minutes for the next. Okay. What about, let's take the first 5. Okay. Take the first 5. So all I have to do is just say semicolon 5. See? So yeah, you get a few minutes, but you have to wait an hour or something. So I would put this in my brochure. Okay. By the way, I'm going to make a brochure. Come to Yellowstone National Park, where every so-and-so minutes, you get to see so-and-so minutes of eruption. How will I do that? Well, in this case, you don't have to do any group by, right? You just take average, right? So if I want to know how long I have to wait, I just have to say data, okay, right? All, and I just want the second guy, right? So that's this, right? So what do? I take a mean that, okay? Okay. Why do you get this funny ratio? Why don't you get a number? Anybody? Because Mathematica will simplify ratio as much as it can, but it will stop from giving you the numerical because numbers are not as precise, right? How do you get a number out of it? You force it. Give me an n. Okay. So on average, it is 1 hour and 10 minutes. Come to Yellowstone National Park, about every hour and 10 minutes, you will see now notice that this thing is kind of like integer. That's why you have to force it. But the first one is not integer, so you don't have to force it. So there it is. Every 3.5 minutes, yeah, 3 minutes and a half. Okay. So every hour and 10 minutes, you will get to see about 3.5 minutes of eruption. Okay. So this is how you get the data, right? But again, I want to visualize it because right now, all I know is that these are different events. I don't know if there's a lot of spread between the length. You know, there's a difference between an average of an hour, 10 minutes. And every time you go there, sometimes it's an hour 5 minutes, sometimes it's an hour 12 minutes. People are not going to complain that much, right? But if the average is an hour and 10 minutes, but sometimes it's 10 minutes, sometimes it's 5 hours, very unreliable. People are not going to be very happy about this attraction, right? Well, it's natural. You can't force nature, but let's say it's a Disney line or something, okay? Yeah. Think of it as Disney line. You have to wait on average of an hour and 10 minutes to play this ride, which lasts about 3.5 minutes. Does that sound reasonable to you? Would you go there? Maybe you will, okay? Well, anyway, so let's see what it looks like. Now, this is already a data analysis, right? You already did an analytics. You take an average, but let's be more clever than that. How about this? I use list plot. Okay. Now, tell me that this is a lot more, does not give you more between this and this. Okay. Yeah, I know now why I choose this example for the book. It's one of those things where once you plot it, you know the story. Okay, remember the value of interactive visualization. Now forget interactive, just visualization. Once you see it, you already have information. Okay, what can you tell about this old faithful geyser? Can't, right? You can't. But how about this? Right? So this is waiting time. This is, so the longer you wait, the longer the show, right? So that's the first thing you get right away. The longer the wait, the longer the show. And that kind of makes sense. You kind of build up, right? So you have to build up volume of steam. It takes you longer, but once it starts eruption, there's more steam. Longer the wait, longer the steam. Makes sense. So you get this kind of roughly linear regression line, right? On average, you would never get, if you get one right now, you can actually go sit on top of the mouth of a geyser and you know you're not going to get blown apart for the next 20 minutes. Well, they won't let you, by the way. It's all fenced off. Okay. But you know, you're pretty safe, right? You're pretty safe. You're pretty safe. You definitely are not going to get another one in the next 20 minutes. So you can actually lie on top of it if you want. Yeah. Anyway, what else, guys? Can you see that there's a little grouping here and there's another grouping here? Now, a geologist look at this and will be able to say, aha, there are actually two cavities inside. There's small cavity, there's big, you know, they can make that kind of thing. So imagine that this insight about the internal configuration of the air pocket or the cavity in underground. You can't see it by looking at this. But you can definitely see it by looking at that. Okay, so that's what I mean by power visualization. Right away, you get insight. Okay, right away, insight. Yeah. So geologists will be able to say, yeah, there's like a small pocket and there's a large pocket. And the ratio is about maybe 2:1. There's a lot more long pocket. I don't know. Okay, maybe they can infer something from there. Okay, but at least the tourist promotion can tell you, you know, don't worry, come in. You don't have to wait more than an hour and 40 minutes. That's pretty good, right? That's pretty good, right? So you almost guarantee. Now this is what Disney line can guarantee you, right? You will get to play on average. Okay, you will get to play, if you come in the morning and leave in the evening, you can get on 3 rides. Let's say 3 rides. How can they make that statement? Well, it's a little bit like this. Okay, if you come in and you just miss the first one, you can expect to see another one within 100 minutes. So that's not so bad. That's not so bad. But certainly maybe 40 minutes. So don't go anywhere far, guys. Okay, so you just missed the first one, go get a sandwich, come back within 40 minutes, And you should have a window of between 40 minutes and 100 minutes. The next eruption is going to come. There. Okay. Enjoy your whatever. Okay. So you go to a tourist shop for 40 minutes. Okay. So that's what I mean by visualization right there. Let's go. Now, obviously, this is the most, okay. So you have that data. So that data, right? And so that's the list plot. Okay, so that's an example. Now you can have something else. Okay, so plot 3D. So this is where you actually have a list of three-dimensional. Now I happen to, in this case, create a ratio of waiting time per duration or something. Okay, so I just make this up. Oops. Oh, so I just name. So I'm just being a little bit more fancy now. I actually keep the name so that I can use this over here as an axis label, right? So it's a bit more fancy, right? It's a bit more. That's all. So I have the word here, duration, but now I create a ratio, right? So now there's some. So now if I look on top, I still get the same thing, same as before, right? Right. But I want to get the ratio as a third dimension. So there it is. Oops. Okay, right. And then again, once it's a three-dimensional plot, you can have different viewpoint and so forth. You will see, maybe not today, but you will see that I actually can make a animation from 3D to 2D, using infinity as a, if you think about it, this picture is 3D, right? But if I back all the way to infinity and I zoom in, you guys are gonna look 2D. So if I took the viewpoint back to infinity, it's like 3D for 2D projection. But anyway, visualizing 1D data on a 2D. Okay, oops. All right. Okay, so this is the histogram. Okay, you guys are familiar with that, right? If you type in, well, you don't have to type in anything fast. Okay, let's skip ahead to well, not skip ahead, skip back to your high school. Your high school. You guys remember normal distribution, right? Okay, so let's do this. Let's create another one. Data number 2. Data 2 is equal to, okay? Now, type in the word normal distribution. Okay. Now, this thing is called normal distribution. Right now, it's not a function, it's a declaration. You want to do something with it. For example, okay, mean of normal distribution, what do you think you should get? 0. Right? What's standard deviation? Deviation. Standard deviation of a normal distribution is 1, right? Okay, how about skewness? 0, right? How about kurtosis? 3. Okay. This is from statistics class, guys, right? So you go to Wikipedia page, you see all that. Again, anyway, I don't want to know information about normal distribution. I want to create a random variable from it, random variance. So I just say random variant. Okay. So my data 2 is equal to random variant. Now, if I did this, how many data points am I going to get? 1, right? So I want to, let's make it 1,000. Okay. So type it like this. Remember the first number, 13415, right? Now go back to the same line, shift enter again. You get a different number. Okay, so every time you randomize, you get a different number. How do you get to the same number? Well, the way you get the same number is you have to control it with what's called random seed. So for example, if I say something like random seed, seed random, okay. I get this. Let's try again. It's different. Oh, I thought you said you can control. Well, what happened is if you put default, it's going to pick up something random still. So I have to put something that I control. For example, 1, 2, 3, 4. Okay, 1, 2, 3, 4. And it's going to say random number generator state. Okay, I don't want to see that. So I put semicolon there. Now, if I did this again, I'm going to get the same number. Okay, so it's very useful. It's random, but repeatable because it's not really random. It's like a coin toss, but it's actually a memory of a bunch of coin toss. Okay, and if you start from the same place, you're always going to get the same sequence of coin toss. Okay, anyway, so that's my data. Now, because it's from normal distribution, when I do histogram on it, histogram data 2, see? Right? Now you're not going to get the same color because again, back on that before the beginning of the chapter 1, I set the default so that it has this kind of pretty color. Okay. So if I say histogram of this, it's something like I think it's plot style or something if I'm not mistaken. No, not plot style. Something like image. No. I'll come back. Hold on. Let me look what I use. Histogram chart style. Chart. Yeah. So if you did this, you get the same thing as I do. Chart style is pastel. Okay. So if chart style is something else, something like okay. Just gonna alternate red, green, blue. Fine. Okay. Okay. I happen to make pastel my default because I think it looks nice in a textbook. Right. So you can see that this is generated. It's not exactly the bell curve, right? Because it's random, but it does look like that. So this is how you visualize one-dimensional data in a 2D. Okay. So let's collapse this one. Interactive visualization. So we got the mathematical. Okay, let me shrink this guy. Let me shrink this guy. We are data point. Okay, 1D data. Okay, we got that. We got 2D data. We got 3D data. Okay, we've done that. And histogram is a very common way of doing things. Okay, so that's histogram is 1D data on 2D histogram. Okay, that's that. There's also 2D data on 3D histogram. So, okay. Now, don't worry about all this. I'm just making it look, multi-way. But basically, the function that you want to do is just this. Okay. Oh, faithful, right? You get the data. Okay. So let's do this. Let's do, yeah. Okay. So let's go to the history, and this will be the last thing before break. What was thing called? Data, right? We just call it data. Okay. Right. This thing is two-dimensional data. So to do this in a histogram, you have to say histogram 3D. There it is, right? Histogram 3D. So anybody see? So it has a two-dimensional, right? But it kind of like lumps data point into bucket, right? What's the word? What's another word for bucket in histogram? Bin, right? Bin, right? So histogram basically put data in bucket or bin. Now, if it's 1D data, then the bin is one-dimensional. If it's 2D data, then the bin is two-dimensional, and the height is just basically the count. Now, sometimes you see something like this, and you don't. It's not nice. It's not nice. What do I mean by it's not nice? It's kind of like jagged. So if you want to get something smooth, yeah, there's a smooth version called smooth histogram. There's also a smooth version of this called smooth histogram 3D. Right? So now it's more smooth, right? Okay. So this is just visualize again, nothing complicated. This is actually just to say, where are the data points? Right now, you can look at this, guys. I mean, you don't need to be a geologist. You can say right now, there are actually two kind of eruption. There's short wave, and there's long and long wave, right? Now, with this 2D, there's another thing called contour plot. Oops. Not contour plot, not density histogram, sir. Okay, right? Density histogram. And finally, if I want something like this, it's a smooth version of it. It's called smooth. Okay. Now, if you were to do this in Python, you need to load what's called matplotlib. And to do something even simple like this, instead of one line, you would need 5 lines at minimum. Okay, probably 10. Okay. Because you have to specify a lot of things. Whereas here, you can specify if you're fussy and picky, but if you're not picky and you're not fussy, you can just say, just give me a default picture. So you don't specify the color, you don't specify the size. If you want to, you could, right? But you know, just give me an idea. That's why for me, it's very quick working tool because I want a quick idea of what my data looks like. Give me a histogram. Give me a heat map. Something that's like this is kind of similar to a heat map. So right now, you know this fundamental function. So the histogram 3D, density histogram, smooth histogram 3D, smooth density histogram. Okay. So let's do that and let's take a break. And when we come back, we go interactive.